My dear students, grade 11. In today's video, we're going to continue what we started, which is studying about aldehydes and ketones or carbonyl groups in general. Again, here, take a look at the learning outcomes. We already have started how to name aldehydes and ketones, and we studied about the formation of aldehydes and ketones from primary and secondary alcohols, respectively, using a acidified potassium dichromate. And we also discussed why the tertiary alcohols cannot be oxidized. Do you remember that? Yes, because it doesn't have any hydrogen to take. We also studied about the reduction of aldehydes and ketones and the reaction of aldehydes and ketones with cyanide ions. And also we have studied or described the mechanism of nucleophilic addition. Okay, now distinguishing between aldehydes and ketones using Fehling's and Tolwyn's reagent, and describing the reaction of CH3CO compounds with alkaline aqueous iodine to give triiodomethane. Let's start. Okay, let's remember the nucleophilic addition. Nucleophile, we said that it's a negative ion, and that negative ion actually attacks the compound. Like here we have the cyanide. It attacks the CO because it has more electron density, right? So here you have 4 electrons just between the carbon and oxygen. So in this place you have more electrons. So when the CN attacks this carbon, the electrons actually repel from that carbon heading to the oxygen, making it partially positive and making the carbon partially making the oxygen partially negative and making the carbon partially positive. So when it attacks, this double bond is broken and the CN is bonded with the carbon. And then now you have here the electrons on the oxygen atom. And so these electrons, you have the hydrogen atom from the HCN, yes, attaching to the O and forming the OH. For ketones, here is one example, adding the hydrogen cyanide to propanone. Again, the cyanide ion attacks the compound at the double bond is broken to bond with the CN, and then the hydrogen attached to the O, forming an OH. Now, the difference between aldehydes and ketones, why they react differently. Okay, to learn why they react differently, what makes them different, you have to look at the functional group. Okay, for aldehyde, the functional group, you know that the functional group is CHO attached to alkyl group. So this alkyl group, as the simple one, can be hydrogen, and this is just for methanol. Okay, so this can be hydrogen or a hydrogen hydrocarbon group, right? All aldehydes have one hydrogen attached to the carbon, which is attached to double bond with the oxygen. Good. For aldehydes can be oxidized because they have one hydrogen to take. Okay, just by using a strong reducing agent or oxidizing agent, right? So it's very active to be oxidized using an oxidizing agent because it has one hydrogen that can be removed. For the ketones, you have R and R. Both of them has to be hydrocarbon group, alkyl groups, as an example. So there is no hydrogen, but they can be reduced. Okay, how can you differentiate between aldehydes and ketones? You can differentiate between aldehydes and ketones using 2 substances or reagent. These reagents are called Fehling and toluenes. Each one of them give different color or changes the color when it reacts with aldehydes or ketones. Remember we said that aldehydes can be oxidized because it has one hydrogen. So using the Fehling solution, this is the first test. Just warm the sample with Fehling solution. If you have a sample, just warm it. If it's an aldehyde, so if you have two samples, you have to warm both of them and add just the Fehling solution. If it's aldehyde, the blue solution will form a brick red precipitate. So for aldehydes, blue Fehling will turn to brick red precipitate, which is copper oxide. The blue solution produces a dark red precipitate, but for ketones, nothing will happen. Blue will stay blue. Okay, this is one experiment just to check what happens really when you're using the Fehling test. So the Fehling is two parts. A, which is copper sulfate, just put it in water. This is mixing it. Okay, this is copper sulfate in water. That's the red solution. Just mix it. And then you have Fehling B, potassium, sodium tartrate, and sodium hydroxide. Again, mix it. This is water and this is the potassium compound. They have to be mixed. So Fehling A and Fehling B are poured together, forming the Fehling solution. So actually Fehling is made of two solutions. Solution A is made of copper sulfate dissolved in water, and Fehling B, which is sodium tartrate, also dissolved in water. Okay, the left tube has some sugar, and sugar has aldehydes in it, and glucose in the right tube. Again, you have to add water for both of them. And as you can see, it has to be an equal amount. Just these are constant variables. You have to make sure that they are both equal amount and shaken. Then put the Fehling solution added to both of them. We said they have to be warm, right? So you put them in a beaker that contain hot water. As you can see, the water or the color is starting to change in the tube on the right. Exactly. Can you see the formation of the red color at the top, at the surface? Yes, there it is. It's changing from blue to brick red color, which is the color of the sulfate, right? The copper sulfate. The formation of red precipitate indicates the presence of glucose, which contain aldehydes. So in here you have aldehydes. This was our video for today, and this was our lesson. I hope you stay well and hope you enjoyed, and stay safe, and hoping to see you soon.